In this video, we're going to cover one of the most common math mistakes that's made in chemistry. And it's with the use of the density equation, which is a very simple equation. But as a chemistry teacher, I've seen this mistake made over and over and over. So I just want to go over a quick math lesson that takes, maybe a minute or two, and then go into doing some density problems where you'll never make a mistake. So like I said, what we're covering today is density and cross multiplication. So I want to start out with this idea of cross multiplication. Some students think that it's just one thing, but it's actually many things. So with cross multiplication, if you have two fractions, okay, maybe 2/4 is equivalent to 3/6. We know that both of these are equal to 1/2. Now, most students recognize that if we're going to do cross multiplication, that simply means that if you take the numerator of the first one and multiply it by the denominator of the second one, then that's going to be equal to the numerator of the second one times the denominator of the first one. And we know this is true because 12 is equal to 12. So we know that cross multiplication works. However, some students think that that's all there is to cross multiplication. Now, what does make cross multiplication really effective is that it eliminates all our denominators. As you can see, when we cross multiply, there are no longer any denominators, and that's really good for us in chemistry. Okay? But what students don't realize is that there's more to cross multiplication. For example, I can just simply bring the 6 up here, and it'll still end up being a true statement. For example, if I do bring the 6 up, it'd be 6 times 2 over 4, and that's equal to 3. And if I move that 6 up, there's nothing there other than a 1 now. And 6 times 2 is 12. Divided by 4 would be 3. So this ends up being a true statement just by bringing the 6 up. That is part of cross multiplication. In fact, I could flip-flop these as well, and I could flip-flop these, okay, or bring this one down. There's so many options with cross multiplication. But let's go ahead and just flip-flop the 6 and the 2. Okay, if I do that, that will be 6 over 4, because the 6 is now up, but now I'm going to bring the 2 down, and that's 3 over 2. Now this equates out to still a true statement. So when it comes to cross multiplication, it's not just this, where this times this equals this times this, okay? It's we can bring things up, we can bring things down, we can bring things up and down, and we can do it either way, okay? We could actually flip-flop these as well. So if we did that, that'd be 2/3 is equal to, and I bring the 4 up there, would be 4/6, okay? And both of these come out to 0.6, repeating as a decimal, or 2/3, okay? So just wanted to make a quick, showing where if we have two fractions, there's lots of things that we can do that lead us to true statements. Now, how does that apply to the density equation? Well, we know that density is equal to mass over volume, okay? And I'm going to do several problems today where I'm going to we have 3 variables. I'm going to fill in 2 of those, and then you're going to have to figure out the missing one, okay? And I see students make a lot of common mistakes when it comes to something like this. Now you might say, well, we can't really cross multiply here because we don't have 2 fractions. Well, we can make this a fraction because density over 1 is the same thing as density. So if we really wanted 2 fractions, it'd be something like this. Okay, so let's go into 3 problems. The first one's going to be pretty easy, okay, and that's going to be where I give you the mass and the volume. And really, this one's really easy because you can just plug this number in right here and this number in right here. So this is going to end up looking like 32.8 grams over 11.2 milliliters. If you divide these two out and round it to 3 sig figs, you're going to get this number of 2.93 grams per milliliter. Now, when my students do this problem, they get it right. Okay, this is plugging these numbers into this equation, not a big deal. Okay, it's when I give like density and mass or density and volume, that things become an issue, okay? For example, okay, what if I gave the problem where I gave you the density, 1.81 grams per milliliter, and I gave you the volume? Well, when students see this and they know that they're supposed to be getting the mass, they sometimes just guess as what they should do. Now, looking at this equation, one of the guesses, I could multiply these together, okay? Or I could divide this one by this one, or this one by this one to get the answer, okay? And what I'm really trying to emphasize in this video is that you kind of like do the right math with cross multiplication, number one. But second, which I think is more important, this is kind of like the big point of the lesson, is that you look at your units and see if the units work out to give you the appropriate unit. If it does, you probably did your math right, okay? But a lot of times if the units don't work out, okay, you definitely did your math wrong, okay? For example, if I'm doing this problem, I got density and volume. I got density and I got volume, and I'm trying to get to the mass, okay? If I'm trying to get to the mass, okay, I am going to do the cross multiplication here, okay? So I'm going to do density times volume, and that's equal to mass times 1, which is simply mass. I'm going to plug the numbers in. The density is 1.81 grams per milliliter, and I'm multiplying that by the volume, which is 3.21 milliliters. And that should be equal to my mass, okay? Now, if I multiply these two together, I'll get the number of 5.81, which is nice, but here's the big point of the lesson. Does the units work out, okay? Or do the units work out? So if I multiply these two numbers together, okay, I'm multiplying these units together. And I have a unit as a numerator right here of milliliters, and I have milliliters as a denominator here because this unit is actually grams divided by milliliters. If you have something on the top and on the bottom, it cancels out. I got to ask yourself, is the gram the unit that's used for mass? And the answer is yes, and that means I did this one the right way. So the answer should be 5.81. So I did a good job just by multiplying those two things together. Okay. Last problem, which is usually the one that gives the students a problem. So the first one, typically no problem. The second one here, sometimes there's a problem, but usually not. It's this last one that gives students the most problem. So I'm going to erase all this, okay, and go back, and I'm going to do where I give you the density of 5.12 grams per milliliter and a mass of 3.55 grams. Let's make that 5 a little bit better. And we're trying to find the volume in milliliters. Okay, that's the prompt. Okay. What I'm about ready to do next, please do not do, because I see students doing this. Okay, I'm just going to multiply these two together. And I want to show you kind of like what happens if you do the same thing that we did last time where we just multiplied the two things together. Let me grab my calculator real quick and plug these numbers in. We got 5.12 times 3.55. And it comes out to 3 sig figs as 18.2. Well, 18.2 what? Okay, and here's the major point. If I'm multiplying these two things together, I should multiply these two things together as well, the units, okay? So whatever you do with the numbers, you have to do with the units, okay? And if I do this, well, there's nothing on the top and the bottom that cancels out. Like this gram does not cancel out this gram, okay? In addition, the milliliters would be on the bottom, and they need to be a numerator if I'm trying to find volume, okay, because it's a numerator here. So the units that you actually would get here would be grams squared per milliliter, which makes no sense whatsoever. So the math that I'm doing here is incorrect, okay? So let's go back to our cross multiplication. And I'm just making two fractions. Remember, density over 1 is the same thing as density. and I'm going to cross multiply. So I'm going to say density times volume is equal to mass times 1, which is simply just mass. And what I did by doing this cross multiplication, I got volume out of the denominator, and it's now a numerator. And like I said, in math, that's a good thing. Now, the volume is still tied to density, okay? So we want to separate the volume from the density. So what we're going to do is we're going to divide by d on both sides. So that's going to cancel out. And then my volume is equal to mass divided by density. The other way that you could have done this is just by flip-flopping these two. Bringing the volume up and the density down would still give you mass divided by density for the volume. So let's go ahead and plug this into our calculator. Okay, mass is 3.55 grams, and the density is 5.12 grams per milliliter. And if you do the division here to 3 sig figs, you'll get an answer of 0.693 milliliters, which is the right answer. And just to make sure that we do the same thing that we did over here, whatever you do to the numbers, you had to do to the units. That's how I knew this was wrong. Well, whatever I do to the numbers, I have to do to the units. Okay, so I have to take grams and divide it by grams per milliliter. Well, if you know anything about dividing fractions within fractions, there's this saying that's called keep, change, flip. Okay, so I'm going to keep these units. I'm going to change this from division to multiplication, and I'm going to flip the units. Okay, so let's go ahead and do that. If I take grams, okay, so keep the grams. We're changing it from division to multiplication, and then we're going to flip the units. So keep, change, flip. And these are the units that I have now. I have grams as a numerator and grams as a denominator, so they'll cancel out, and I'll be left with milliliters as my numerator, and that's how I know I did the right math when it comes to the density equation. Okay. Now, there's going to be other equations that we have in chemistry where you're going to have to manipulate it to form new equations. So once again, we could take this density equation here. We could do some cross multiplying to get density times volume is equal to mass times 1 to get this equation. We could divide by d on both sides to get this equation, or simply flip-flop these. But from this density equation, you can get these other two equations. Okay, and we do this a lot in chemistry. We'll do it with the molarity equation, which is molarity is equal to the moles over the volume. We'll do it with PV equals nRT, where we'll have to move some variables around. So understanding how to cross multiply, it's not just good for density that we learned in the beginning of chemistry, but it's going to be used throughout all of your introductory chemistry problems that incorporate various variables that you have to move either to the left or to the right side of the equation. So I hope that was helpful. This was a lesson on really the idea of cross multiplication, and that we can move these variables around from the left-hand side to the right-hand side, or how to deal with denominators. And I hope that was helpful for you.